Hello, this is Naser Alajmi, and my project presentation is on mechanism of solid-state atomic diffusion. I will be explaining the mechanism of solid-state atomic diffusion. Diffusion is the phenomena of atomic motion which driven by higher atomic concentration to the lower atomic concentration, trying to achieve equilibrium, and it's occur in gas and gas, like a perfume sprayed in the room, and it's in liquid and liquid, like mixing of a dye, and solid to solid, like steel's carburizing. So we are talking about solid state diffusion. So solid state diffusion is when both diffusing and host elements are in solid state, and driving force is concentration gradient, and solid state diffusion is the slowest of all three state diffusion, which is gas and gas and liquid to liquid and solid to solid. It requires a high temperature and requires a longer time. And now, what are the mechanism of solid state diffusion? There are two mechanisms, which is vacancy diffusion and interstitial diffusion. So now, before moving on, there's a video I want to show you which tell you these are atoms of host element, and they are arranged so vacancy diffusion is when both host atomic and diffusing have similar atomic radius. So this will make sense that diffusion atom will have to move to atomic radius by either replacing the atoms already present in the host element, or it has to move through vacancy. So if it's going to vacancies, the vacancy, once the atom jumps and fill vacancy, it create a vacancy where it was already. Then the next atom jumps to that vacancy, and so on. This is the process going on. So this is a slow form of diffusion. Consider that the same lattice we showed you before. So this red atom is the diffusing atom. You can see step by steps atoms are jumping and the diffusion is happening. So now coming to the interstitial diffusion, when the host atom and the diffusing atom has a big difference in the atomic radius, then these are the lattice spaces. As you can see, they're present. They're already present. If there is a smaller atom than that, then the diffusion will be interstitial diffusion, and it's faster than the vacancy diffusion. Let's consider this is a vacancy atom moving between interstitial spaces. And this is called interstitial diffusion. Now comparing vacancy and interstitial mechanism. So vacancy is similar atomic radii. Interstitial needs larger difference in atomic radii. Vacancy is slower, and interstitial is quite faster. Vacancy needs activation. The activation energy is high, and the interstitial is lower activation energy. Vacancy requires a high temperature, and the interstitial requires quite lower temperature. Which affect diffusion rate for both type of mechanism are state of diffusing species, temperature, activation energy. So state of diffusion species is if it's solid diffusing to solid state, and temperature, higher the temperature, faster is the diffusion. And activation energy, if activation energy is higher, diffusing will be low because it requires a high temperature to start diffusion. And if activation energy is lower, then the diffusion will be fast. And that's all. Thank you very much.